All right, youngins, today we're going to talk about absolute value equations. So an absolute value equation is any sort of equation that contains an absolute value expression. Absolute value you'll see here are the vertical bars. It's kind of like parentheses, but the absolute value of a number is describing how far that specific number is from zero. So for example, here we have the absolute value of 2x plus 3 equals 5. Think of this as asking you the absolute value of what number is going to equal 5. So on a number line, we are looking for what numbers would be 5 units away from 0. So on the right side, we would have positive 5. And if we were to think on the left side, we also have negative 5. I need to go one more there. So negative 5. So those two numbers would be 5 units away. That means whatever's inside, 2x plus 3 can equal 5, and 2x plus 3 can equal negative 5. So because there are two options due to the absolute value, that means we have two equations that we are going to solve separate, and our goal is to figure out what values of x would make those equations true. In this case, we're going to have two solutions. All right, so let's look at our first examples here. So we're going to solve these equations, and we're going to graph our solutions on a number line to represent what they mean. First one, we have x minus 4 equals 6. So again, what we have to think about here is what value, think about inside the absolute value, what values would I plug in there that would give me 6 after I take the absolute value? So the two options here would be 6 and negative 6. So what we're going to do is write two equations. X minus 4, whatever's inside, could equal 6, or x minus 4 could equal negative 6. Okay, so I'm going to solve two equations separately, but how I solve them is going to be the same. Goes back to our inverse operations. To solve, all I need to do first is add 4 on both sides. So if I add 4, here I will be told that x is going to equal 10. And then lastly, down here again, I'm going to add 4, but now we're adding 4 to a negative 6, so I'm going to get a slightly different answer here. So my value would be negative 2. All right, so if I were to graph these things on a number line, okay, so since I have negative 2, I'll start with negative 2 on the left side. So I'd have negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just wanted to make sure I had all those squeezed on there. So that means my two solutions would be there and there. Now, the reason why I want to show this on a number line is, again, we are looking like, for the last example, two numbers that are equally away from 0. So in this case, and this is kind of what you did in your little exploration, the distance between these 2 points, and I'll draw this here, think of this as like a segment. The distance between those 2 points is 12 units, okay, 2 plus 10. So the thing about this, what is half of 12? Well, half of 12 is 6. So that means, think of this, if I were to go from, let's say, negative 2 and move over 6, I'd be at negative 1, 0, 1, 2, 3, 4. That's going to put me right here at a value of 4. Okay? And notice that that value is directly in the middle, so that both of these numbers are not 4 units away, but are 6 units away. Now, it's interesting that we are looking for the absolute value of some number that gives me 6, but that middle value that I found is 4. Well, notice in my equation I have x minus 4 and 6. So essentially what happens is that we're normally be looking at 0, but the minus 4 shifted that over 4 units, and then now we're looking at 6 units on either side of 4. Okay, so that's how you can kind of visualize this thing graphically, but again, our goal is to try and solve things algebraically. All right, next one. We have 3x plus 1 equals negative 5. So again, what I'm looking for is what absolute value of what numbers would give me negative 5. Okay, so we got to be careful here. A lot of you are going to think, okay, we can plug in 5 and we can plug in negative 5. But this one's kind of got a trick in here. We want to try and find the absolute value of two numbers that give me negative 5. The key thing here is we talked about that the absolute value can never give you a negative answer. It's just looking at a distance. So it's saying how far is that number away from 0. Negative 5 doesn't make sense. We cannot have a negative. We are just focusing on the value. So in this case, since the negative, and we did talk about if a negative was in front, but since the negative's on the opposite side of the equal sign, and there's nothing else over here with 3x plus 1, The absolute value of a number can never give me a negative, so that means in this case, for this problem, there is no solution. Okay, so if we ever see a negative on the opposite side, now there's one rule breaker and we'll go through that, but in this case the absolute value of a number can never be negative, so it's not a solution. All right, now next example is similar to what I just talked about, okay? So in this example we have 3x plus 9 inside the absolute value, but now notice how we have minus 10 outside equals negative 4. Now what I just mentioned before is that we do have a negative 4 on the other side of the equal sign. So based on what I just said, you might be thinking, wait, no solution. But notice how this minus 10 on this side is outside the absolute value. So what we want to do is we almost want to treat the absolute value like its own variable, where the first thing we want to do is try and isolate the absolute value, meaning anything in front or behind is something we want to move to the other side. So if I see minus 10, what I want to do is add 10 to both sides. So that would give me the absolute value of 3x plus 9 equals negative 4 plus 10 would give me 6. Okay? Now, once I have the absolute value isolated on this side, notice here I have a positive 6. So if that number is positive, I know I can get an answer. So here's what I'm thinking. The absolute value of what number would give me 6? Well, I know then that the absolute value of 6 and negative 6 would give me 6 if I take the absolute value of them. So I can set this up then two equations. I would have 3x plus 9, that's what's inside, could be equal to 6, or 3x plus 9 could be equal to negative 6. And now we got to solve both the equations the same way. So again, when solving these, all right, I'll draw a line all the way down the middle. We got to do the inverse operations. So first one I'm going to do is minus 9. All right, so if I subtract 9, both sides, that'll cancel. Heck, I can minus 9 down here. I'll just do 2 at once. What I would then get is 3x equals negative 3 in this case, and then 3x equals negative 15 over here. Okay, and then next thing I have 3x, which means I'm multiplying, so my goal is to do the opposite, which is to divide. So I'll divide both sides by 3. And on this problem, I'll get x equals negative 1, and here x equals negative 5. Okay, now I know my answers are negative. Don't get confused, because remember the x's are things that we are plugging in. So if I take negative 1 and plug it in for x, I'd have 3 times negative 1 plus 9. Okay, and the same thing here with negative 5. I'm plugging it in, but since it's going inside the absolute value, that's okay. All right, so if I were to graph my solutions on the number line, okay, I'll start with negative 5, negative 4, negative 3, negative 2, negative 1, and 0. So that means I have my first solution at negative 1, my second solution at negative 5. Okay, think about this one again as the distance between them. You don't have to draw that line, but I like to just show that. Notice here, if I were to cut down the middle, we're thinking about these two numbers being, in this case, 2 units away from that middle line. Okay, now how that relates to the problem, notice how this one, because we got a lot of business going on, it gets a little bit more tricky to kind of understand. All right, so now we're going to do a little word example using the absolute values. All right, so it says in a cheerleading competition, the minimum length of their routine is 4 minutes and the maximum length of their routine is 5 minutes. So we're going to write an absolute value equation. So the key thing is we're going to write an equation that represents these minimum and maximum lengths. So we know that the minimum length is going to be 4 and the maximum is going to be 5. So think about this, we can use a number line, okay? My low end, my minimum performance is going to be 4, my maximum is 5. So what I've been showing you so far is that whatever the absolute value is, again, is the distance away from 0. But what we're looking at when we don't have a value, like we don't have just 0, in this case we have 4 and 5, we're going to think about what's the halfway point between 4 and 5. Okay, what's the middle point? That value inside my equation, I'd have the absolute value of x. Now, since it's not just 0, since we are shifting this graph over, we are going to move this over to that middle point. And that middle point halfway between 4 and 5 would be 4.5. So 4.5 is going to go inside the absolute value with x. Okay? And that's going to be equal to, now, again, it's how far away your numbers are from that line. So how far away is 4 from 4.5, and how far away is 5 from 4.5? In both cases, it is 0.5 units away from that middle value, so that means I can write equals 0.5. So in the end, my equation would be the absolute value of x minus 4.5 equals 0.5. So that would be my equation. Now to check your answers, if I were to plug, let's say, 5 in here. So I'll do it off on the side. The absolute value of 5 minus 4.5, so that's my maximum value, gives me 0.5. So the absolute value of 0.5 is 0.5. So that's the high end. If I were to do the low end, so I do 4 minus 4.5, that's going to give me the absolute value of negative 0.5. But again, since we're looking at an absolute value of a negative, that's going to give me 0.5. So it's essentially saying that both of those are within a half a minute of each other. Okay, so this concludes the first part of absolute value equations. We are going to finish this up by solving more complicated absolute value equations that contain multiple variables or multiple absolute value equations.